guys should be able to hear me. And then desktop audio. Test, test, test. Yeah, it's working now. Okay, good. Was this working in the beginning? No, I've been streaming for 8 minutes and I've done nothing there. Yeah, there's no audio this whole time. Okay. So what I was saying is that since yesterday, since I did this and realized I didn't know why I'm doing anything, I'm just gonna study these 3 videos today. And yeah, I only have 30 minutes, so we'll see how far we go. And I think you should be able to hear the audio as well. Let's see.
In this video, we'll be discussing fatty acid oxidation.
Oh, I don't think it's
Our main
working.
source of stored energy is fat triglycerides.
Oh, it is working. Okay.
Triglycerides are a great way to store
Okay.
energy because being very nonpolar, they don't come with a lot of surrounding water molecules. This is not the case with, say, glycogen. Glycogen as another energy storage molecule, but glycogen is very polar and so has a lot of associated water molecules with it. Triglycerides are a much more efficient way to store energy because they don't come with that water.
Okay.
However, we have to triglycerides. Triglycerides are a great way to store energy because being very nonpolar, they don't come with a lot of surrounding water molecules. This is not the case with, say, glycogen. Glycogen as another energy storage molecule, but glycogen is very polar and so has a lot of associated water molecules with it. Triglycerides are a much more efficient way to store energy because they don't come with that water. However, we have to first get the fatty acids off of the triglyceride. And so, the first
Triglyceride.
enzyme that we're going to use to break down fats is an enzyme called lipase. And the lipase is going to create an empty glycerol and 3 fatty acids that can go through fatty acid oxidation. The glycerol can be recycled by the liver and gluconeogenesis and other carbohydrate metabolism. The fatty acids are then going to be broken down, essentially 2 carbons at a time. And those 2 carbon units can then be put into the Krebs cycle to generate reduced electron carriers for us. So let's take a look at that process. Let's get ourselves oriented here. This would be the matrix of the mitochondria down at the bottom. This would be the cytosol up here. We can see the double membranes, the outer membrane and the inner membrane of the mitochondria. Fatty acid activation happens in the cytosol, and this essentially involves attaching a coenzyme A to the fatty acid. This is going to cost us a couple of ATP to kind of get things going here. So a couple of ATP coming in there. And then we're going to move that activated fatty acid into the mitochondrial matrix, where we're going to break it down 2 units at a time, 2 carbon units at a time. And if you look here,
This is very familiar with yesterday's passage. It's actually I want to see the passage as I see this video.
this guy
Because okay, this takes 2 ATP to remove this. This is hydrolase, hydroxy something, because we're removing this alcohol from a carboxylic acid. And this is saying that we're removing 2 carbon at a time, which is very reminiscent of what I did yesterday. Okay.
here with its 2 carbons is basically an acetyl CoA unit. So the idea is we're going to break that thing off and we're going to put the acetyl CoA into the Krebs cycle, also which occurs in the matrix, and generate reduced electron carriers for us. Let's take a look at this data oxidation process in a little more detail. Here's our activated fatty acid, and the first thing we want to do is to oxidize it, and we're going to add this bond here. We're going to basically remove a couple of hydrogens and generate a double bond. So the enzyme we're going to use to do that is called a dehydrogenase. When you oxidize something, we're going to oxidize this bond here, you're going to have to reduce something else. So the molecule that gets reduced is an FAD. We're going to create an FADH2 in this step, and a double bond here between these guys. And then in a couple of steps, we're going to do another oxidation, this time on this carbon, essentially attaching an oxygen here, much like our double-blinded oxygen here. So I'm just going to kind of draw that in right now. Of course, we're going to get rid of this double bond. And because we are doing another oxidation, we're going to have to reduce something again.
Okay.
In this tutorials. That's very. Do you know what you're working on tomorrow?
Oh yeah, tomorrow Dr. Hayward said he wanted me to come in a bit later because he wanted me to stay later because he wants to show me. I think so. Let's see. He said, okay, if possible, please come in later at 10 a.m. this Friday only. Join us for the brain sectioning demo. 3 to 4. Oh, he did? Oh, I didn't know that. My bad. Then in that case, oh, well, I'm doing the thing with her tomorrow, like this thing. Other than that, I never know what I'm doing until yeah, but yeah. Other than that, no. Oh, in the morning? Okay, sure. What time? Like early nine or something. Okay. Okay, sure, sure. No, no worries, no worries. No, that's fine, that's fine. I'm always late too. Okay, okay, cool. What are you collecting again? Oh, I've never tagged a mouse yet, so. Oh, okay, 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 okay. Yeah, sure, sounds good. Okay. Are you starting? Okay. After you're done with that. Okay. Damn. With different people? With different people? Tough. But you're still alive, so there's that. Oh, you guys are thinking the same thing. No, let me keep my free time for now. How many? How many meetings? Why? It's just onboarding, like all trainings. Oh, okay. Mm. He even moved to the lab meeting to make sure I was there, so I'm starting to get a taste. But I want to be at lab meetings. I think it's important. So yeah, yeah, yeah. I can imagine. It was really for me, Ryan, Jacob. That's it. Now your keys are very colorful. You will.
In this case, we're going to reduce a molecule of NAD to create an NADH. Then we're going to attach a coenzyme A to this carbon. And so just kind of imagine that for a moment. If you've got a coenzyme A here, now you have two units that look awful similar. You've got this guy here, you've got this guy here. And so we're just going to break them. We're going to break them right there. And what we end up with is a 4-carbon unit with a coenzyme attached and an
Oh, H3C. Yeah.
acetyl CoA that can now go into the Krebs cycle. So we've got a couple of steps here in this thiolase, which is going to attach to coenzyme A and break the molecule in half. Not really.
Yeah. Oh, okay. Light this? Yeah, sure. I can light the Bunsen burner. Well, I think I have to go. So.